morning, good afternoon, good evening, depending on whatever time zone you happen to be joining us in. This is Kenneth Wong, Senior Editor for DE 24/7. Today, we are speaking to Michael from Nexa 3D about 3D printing industry, the industry that is evolving quite a bit. So, Michael, welcome. Would you mind saying a few words about your company, the market you serve?
Okay, to start off with, thank you, Kenneth, for having me on the podcast. I'm happy to take a bit of time and speak to you about the perspectives of myself and Nexa 3D on the additive industry. Nexa 3D is a company from Ventura, California, and we are approximately 5 years old, and we are in the photopolymer resin-based area within 3D printing, and our niche is building industrial scale polymer processes with an open materials platform. And I guess what our real claim to fame or secret sauce is that we are able to harness a light engine technology and a curing layer technology that can make our printers go extremely fast. So this is really enabling extremely high throughput, as well as even down at the desktop level now. Recently, we announced a new product called the Zip, which gives prototypers the ability to also print very quickly. So this has the benefits of either throughput in the volume manufacturing space, or just design iteration pace at the prototyping side of things. So that's the company. We have approximately 70 people, I believe, on board now, and we're growing very quickly. And we have big dreams in the additive industry.
Michael, what are the market segments that you serve? And in the last 1 or 2 years, a lot of manufacturing businesses changed quite dramatically because of the pandemic. Do you notice any kind of dramatic changes in the market segments that you serve?
Yeah, sure. Thank you. So I mentioned we are a polymer-based company, a photopolymer-based company. We also have thermoplastics with our larger industrial SLS machine. So that is where we're fitting initially. And traditionally, we've gone after these areas that have high throughput needs, with the leaning towards a functional product, an end-use part that we want to help people manufacture in scale. In terms of what we've seen growing, obviously the pandemic has changed a lot. So we're seeing, I guess, against the backdrop of just sort of a slow increase in the number of people that are transitioning designs to end-use parts. On top of that, COVID, I think, brought a big emphasis on biomedical and medical products, areas where we saw that the supply chain necessarily couldn't keep up. 3D printing was able to really step in the gap there and quickly certify workflows to be able to provide for those use cases. So that's probably the two areas where we've historically placed ourselves and wanted to help the marketplace.
3D printing started out as a prototyping method, but now, like you have pointed out, a lot of people are exploring the ideas of using it for mass production. What's the difference? What's the difference between using AM for prototyping and using it as a manufacturing means?
Yeah, I've just always felt that this really came down to the caliber and quality of the materials that are available, in conjunction with a particular 3D printer's print process, to be able to access those functional properties. In the beginning, when prototyping, the materials were not as mature, they were great for form and fit type prototyping, but not necessarily maybe ready for functional prototyping, and definitely not ready yet for end use parts. And so as the industry has matured and larger players have become more excited about it, they've brought their expertise to bear to solve that problem. So as that problem is being solved, you're seeing more and more of these technologies and go into end use parts. So that's, I think, the big difference that has changed. But what's really cool now is that we're at this point now where we have these validated materials and these validated workflows that work for end use parts. So now the idea is, okay, well, let's start doing that at the very beginning. So let's prototype with that validated workflow and use those types of materials at the very beginning, So when it does come time to scale up and you're going through, 10 units to 100 units or 100 units to 1,000 units, you know that there's going to be a validated workflow for you to grow into, and you don't have to, have this friction point of revalidating a new material or switching to a new technology. So kind of working the process, inverting the pyramid here is really going to help prototypers get to their final part faster by being able to leverage those ecosystems of materials from the very beginning.
What's your advice on identifying the right kind of product or the right kind of part or projects for additive manufacturing?
Sure. Yeah, I forget who said this, and I once heard it was said that for traditional subtractive manufacturing, the more complex or the more holes you drill into something, the more expensive it becomes. For additive manufacturing, the opposite is true. The more holes you create, you actually make the part cheaper because you're using less material, and by the nature of the print process, it can handle as much complexity as you can throw at it. So when I think of parts that are good for additive manufacturing, it's sort of a combination, well, at least for prototyping, we'll start there, a combination of both, low numbers where the design itself hasn't maybe crystallized into exactly what you want. So you still want to try a parameterized space where you want to find hone in on your right design, and you need a lot of iteration. So that's one aspect. The other aspect is complexity. You want to be able to take advantage of the uniqueness of the additive manufacturing process to be able to achieve complexity almost kind of at zero cost. So things you would like to add more complexity to, or more complexity gives you better properties, whether that's through lightweighting with the lattice, or doing generative design to make sure that you just need enough material in the right places to achieve your functional outcomes, your functional objectives. Those are things that are really well designed for a 3D printer. So then I guess the last one I think is time. If you don't have a lot of time to get to your end result, having a tool like a 3D printer in your office space or in your lab space is really like a gift, because it can basically just let you go faster, and in conjunction with your design and actual printing, you can have a much quicker, tighter loop of design and feedback to get to your final part much quicker. So those are, I think, the areas where the AM is your best bet. I sometimes see people say, "Oh, I want to print out a plate or a flat stock or a tube or something that traditional manufacturing does really well." And sure, you can do it; it's totally possible, but may not be leveraging all the great superpowers that an additive process has.
Very good point. So, Michael, are there any customers, specific examples of usages among your customers that bring out what you call as the superpower of 3D printing?
Sure, Kenneth, great question. Well, there are a number that come to mind. I think one that I would like to highlight here is that we worked with a mobility company called Arcimoto, and they make this really amazing bike or e-bike that allows people to, modern mobility. And I think one of the nice things there is that this is, a traditional, typical steel frame that needs a lot of performance. And we've, a lot of times there's a question about, okay, do you need a metal 3D printer? You only have a plastic 3D printer. How can I help you? And this was a very interesting case where we have a metal casting product that actually prints the positive of your part in a wax-like substance, which then can be burnt out in an investment cast or a lost wax casting process to then use metal to make that final part. So you're getting both the benefits of any kind of generative design you'd like in that actual part, because you're using a 3D printer to create the positive, and you're also being able to get the benefits of whatever final metal or steel you want to use in that design for your final physical properties. So it's kind of a really cool way to look at achieving best of both worlds, where you get your complexity and you also get, the metals and the steels that you're used to in that final product. And so that's, I think, really a really cool example of how we've been able to help a company achieve a better part, and a really great outcome for that particular application.
Right, very good. Michael, thank you so much for sharing your insights and experiences with us. I really appreciate it.
Thank you very much, Ken. Anytime.
All right, until next time, this is Kenneth Wong for DE 24/7, and we are out.